The first four calculation steps that we have seen are full load design calculation step. The last calculation step, simulation, is going to take into account the dynamic partial load behavior of our system, which will be influenced by the exterior air temperatures of our system. So what's very important is that for this step, all of the controls also need to be implemented. Here, for example, the control strategy is to activate our distribution pump when there is demand from any one of our end unit circuits. This is simply hysteresis, which transform our modulation signal into an activation signal, and these are all joined into an OR gate, so that if any of them have demand, our pump will activate. To simulate, we can choose when we want the model to simulate, for how long, and where. The where will have an impact on those exterior air temperatures, whether that's on the end units, who will need to produce more heating if it's colder outside, or on the evaporators of our air source heat pumps, which are linked to the exterior air temperature. Now that the model is simulated, we can have a look at the results to check that everything is working as it should. On this graph, we can see this is the set point of the heat emitter, and this is the heat that is emitted. So we can see here the heat is not being met. The heating demand is not being met. Let's check if this is due to one of the other end units taking too much heat. No, here we see the same behavior, and on this one, again, we see the same behavior at the same time. So this tells me perhaps the pump is not being activated. Here, in fact, it's being activated even stronger. Okay, so it's not a problem coming from the controls on the pump. If I have a look at the temperatures inside my buffer tank, those are all good, and then there's a dip. So that's telling me it looks like the problem is coming from the production side. Okay, if I take a look at my heat pump, the heat flow on my condenser, here I can see my heat pump is being turned off. So if I go into those controls, we've got our activation signal, which is in this case always on. Then we've got our activation with respect to the exterior air temperature. So here we can see the exterior air temperatures. And here, I think this might be the problem. We can see we've got an off trigger at an evaporator temperature of -5. And here we're going below -5. So if I look at my output value, yes, exactly. We can see that our system is being turned off. Okay, so here a few different things we could do to solve this. Either we could put perhaps a larger buffer tank in order to try and bridge that time at which the installation is at smaller than -5. We could take away this safety. Of course, this is just trying to protect the COP of our heat pump. We could also install a hybrid system where we would have a boiler as a backup if the temperature goes below a certain temperatures. All those are valid solutions. We can also hover over most of the components to get the kind of overall important information. So how much heat has been outputted by that unit, what was the operation time, how many start stops for a pump, what was its energy consumption, and we can like that hover over all of our components to read the energy flows.